When students have mastered the decade structure of the number system and understand that all numbers within 100 are composed of 0 to 9 ones and 0 to 9 tens, they are ready to add and subtract 10 within 100. Students often learn to add 10 by dropping down one position on the number grid. However, this strategy is only helpful if you are actually looking at a number grid. A far more powerful strategy is to use what we know about making 10 to add 10. For example, to make 10 with 1, we need 9. To make 10 with 9, we need 1 more. Thus, 1 plus 10 equals 11. This strategy works in any decade. Because we have 1 1 in 11, we know that to make 10 with 1, we need 9. To make 10 with 9, we need 1 more. Thus, 11 plus 10 equals 21. Of course, this strategy works with any number. For example, if we are adding to 6, we know we need 4 to make 10 with 6, and 6 more to make 10 with 4. Thus, adding 6 plus 10 equals 16. If we are adding 10 to 16, we have 6 ones. We know we need 4 to make 10 with 6, and 6 more to make 10 with 4. Thus, 16 plus 10 equals 26. The strategy of making 10 to add 10 helps to reinforce and deepen students' understanding of the decade structure of the base 10 number system. It also provides the foundation for a very important strategy that students will use to master multi-digit addition and subtraction, and also need in order to construct the meaning of multiplication. This strategy is called decomposition, or breaking a quantity down into 2 or more smaller parts. We are simply using what we have learned about number composition in reverse. For example, we can break the problem of subtracting 10 from 13 down into the problem of subtracting 3 from 13 to get 10, and 7 from 10 to get 3. Thus, 13 minus 10 equals 3. The advantage of this strategy is that it works in any decade. If we want to subtract 10 from 23, we can subtract 3 from 23 to get 20, and 7 more from 20 to get 13. Thus, 23 minus 10 equals 13. The MathRack number grid is a numeration model of decomposing 10 to add or subtract 10. It is also important for students to develop an understanding of this strategy in magnitude. In this example, we are modeling 12 plus 10 on the number line. We know that when we start at 12, the next 10 will be 20. We need 8 to make 10 with 2, and 2 more to make 10 with 8. Thus, 12 plus 10 is the same thing as 12 plus 8 plus 2, which is 22. Again, the advantage of this strategy is that it works in any decade. Here, we have 2 ones and 8 tens. The next 10 will be 90, and we still need 8 to make 10 with 2, and 2 more to make 10 with 8. Thus, we have shown that 82 plus 10 is the same thing as 82 plus 8 plus 2, which is 92. To subtract, we reverse the decomposition of 10. We know that 27 is composed of 2 tens, or 20, and 7 ones. Thus, if we subtract 7 from 27, we will have 20. We must subtract 3 more, because 3 makes 10 with 7, which puts us at 17. Thus, we have shown that 27 minus 10 is the same as 27 minus 7 minus 3, which is 17. Once again, this strategy works in any decade. We know that 97 is composed of 9 tens, or 90, and 7 ones. Thus, if we subtract 7 from 97, we will be at 90. We must subtract 3 more, because 3 makes 10 with 7, which puts us at 87. Thus, we have shown that 97 minus 10 is the same as 97 minus 7 minus 3, which is 87. Adding 10 can be assessed with simple strings, but this is not as uncomplicated as it may at first appear. Both teachers and students often take the shortcut of increasing the value of the digit in the tens place by 1. While this will give a correct answer when adding 10, it does nothing to help the student with multi-digit addition generally, nor will it prepare them to construct the meaning of multiplication. While it is advantageous for a student to know this shortcut, a student who understands what it means to add 10 should be able to explain why the shortcut works. For example, when adding 10 to a number with 4 ones, I need 6 to make the next 10, and I will always have 4 ones left after I take that 6. So I can just increase the number of tens by 1. Similarly, subtracting 10 can be assessed with simple strings with the same caveat. Students should understand that they can subtract 10 simply by decreasing the value of the digit in the tens place by 1 and keeping the same number of ones. However, students should be able to explain why this works. For example, when subtracting 10 from a number with 8 ones, I know that subtracting 8 will send me back to the previous 10. Then I need to subtract 2 more, because 2 makes 10 with 8, and that will leave me in the previous decade with 8 ones. When we are adding 10, the decomposition strategy consists of breaking the 10 down into 2 parts. The part that is needed to get to the next 10, or the end of the current line on a MathRack number grid, and the part of the 10 that remains. When we are subtracting 10, we break the 10 down into the part that is needed to get to the previous 10 and the part that remains. While it may not be apparent at this stage, students who learn to add and subtract 10 using the decomposition strategy will have an enormous advantage in multi-digit addition and subtraction, as well as multiplication.